Alright, welcome to our lesson today on the properties of linear relations. Right, so today we will determine whether a relation is linear or not, and find the rate of change in a linear relation if it is linear. Right, so starting off is a pretty common scenario you'll encounter on renting a car. Right, so in this case, if we are 0 kilometers, it costs us $60, which means that in order to actually start renting a car, we have to pay $60 first. And then at 100 kilometers we've driven, we'll be paying $80. And at 200 kilometers we've driven, we'll pay $100, so on and so forth. Right? And we notice that when we plot it down, it's a nice straight line on this graph. And so if you were to say, oh, what happens when we drive, say, 156 kilometers? Right? We can just look at the graph and say 156 kilometers, that's around here-ish. And according to this graph right here, the y is the cost, which means that this will run us around, say, $90-ish, right? So a linear relation is very helpful because we can extrapolate or kind of predict or guess where the data is based on a relation. We don't really know what the cost is at 156 kilometers, but by putting it on a graph, we can kind of guess or kind of predict what's the price. So with that being said, is this linear? So the definition of a linear relation is if everything goes up by a constant amount. So if something is linear, then it means the change is a constant amount, right? Or the same amount. So let's check it out then. Looking at the distance here, we've seen that this is going up by 100 each time, 200 to 400, right? So this is constant because the distance is increasing by a same amount every single time. Okay, then how about the cost then? And let's see, 20 or 60 to 80, that goes up by 20. We go by 80 or 20 again, we go by 20, we go by 20. Right? So the change in this cost is also constant. So now if those variables change at a constant rate or they change at a fixed amount each time, then this right here is considered a linear relation. Yippee, linear. Right? They don't have to be the exact same change, right? As you can see here, the distance goes up by 100 each time, the cost goes up by 20 each time. Even though it's going by 100 and going by 20, even though the change is different, as long as it's constant for both variables, it is considered linear. So now you might wonder, okay, well in this case, what if I want to go 500 kilometers, right? It's not the data point, it's not a graph, then what can we do? This is where we have to find the rate of change, right? The rate of change is only used for linear relations, and it tells us how much is our little constants changing. So all we have to do is, you might have heard this before, it's called rise over run, or the change in the y-axis as a fraction over the change in the x-axis. Right? The changing y over changing x, or the rise over the run. Okay, so what does that even mean? Because we need to find the changing y and changing x, we need to find 2 points so we can actually compare them and see how much they're changing. So let's take this point here and this point here. This point right here is that x is 400 and y is at 140, right? So that's x is 400 here, y is 140. And then the second point, we are at x is 300 and y is at 120. So now we just look at the changes. So in order to go from this point to this point, the change of y will just be 140 minus 120, right? Because again, if we're going from here to there, we're just subtracting this y by this y. And similarly, the change in x would just be 400 minus 300. Right, so this is what the rise over run means. The rise is a change in y, the run is a change in x. Okay, if we subtract that, we get 20 over 100. After reducing, we get 1 over 5. So that's a rate of change. So what this is telling us is that for every 1 kilometer we drive, it will cost us 1/5 of $1. To put that all into an equation, we can say the car rental cost, say cost right here, equals to 1/5, because that's the rate of change, the 1/5 of the distance plus the initial cost, so plus 60. So this is why the rate of change is really useful, is because we can use this rate of change to kind of predict or figure out a value that's not on a graph. Right? So for example, let's take 250 here, right? 250, it goes to this point right here, but we don't really know what this is, right? We can kind of say it's around, let's say 110-ish, but we don't really know. So what we can do is to plug in the distance. So the cost is 1/5 of 250 plus 60, right? And if we do that, we get $110. Right? So the rate of change is a quick way to tell us how fast is this graph increasing, and the exact value of something. Okay, so now let's try some examples here. Very simple question. Are the following relations linear? Okay, so once again, a relation is linear as long as it increases at the same rate. So this is pretty much saying that, at 0 Celsius is 32 Fahrenheit, at 15 Celsius is 59 Fahrenheit. Okay? So each increase for the Celsius goes up by 5. Each increase on the Fahrenheit, let's see, goes up by 9. Right? So 41 to 50 is plus 9. That's plus 9. That's plus 9. Right? Which means that this relationship is linear. Right? Because they're both going up at a constant rate. Okay, now how about a graph? Y equals to x plus 2. Right? As a reminder, to do a graph, just do a table of values. So let's do 5. Generally, 3 is usually enough, but let's do 5 just to practice too. Right? So x, y. Okay, when x is 0, y is 2. Right? Because we just plug 0 into there, 0 plus 2 is 2. When x is -1, y is -1 plus 2. Right? We're plugging the -1 in here. That's +1. When x is +1, y is 3. When x is -2, y is 0. When x is +2, y is 4. Okay, so those are 5 points we can plot onto this graph. Alright, so we can do our graph here. So 0's in the middle, we got 2 here, 2 here, -2, -2. Okay, so our first point is x is 0, y is 2, so it's right here. We have x is -1, y is 1, right here. X is -2, y is 0, right there. X is 1, y is 3, x is 2, y is 4. And from there, we can see that this is a linear relation, right? Because when we graph this function out, it is a completely straight line, which means that it is linear. Okay, so now let's do another one. Y equals to x squared. So we got x and a y here. So same thing. X squared, which is 0 squared is 0. -1 squared is 1. 1 squared is also 1. -2 squared is +4. 2 squared is still 4. Which means that when we draw out our graph, okay, so we're starting at 0, 0. Right, we have x is -1 and +1. So right here, x is -2, y is 4. So this goes up to there. When x is 1, y is 1. X is 2, y is 4. So we'll get a graph like this. And as we can see, it is a curve, or what we call a parabola in math. Because this is not a straight line, then this means it's not linear. Right? So this is linear, and this is not linear. And that's pretty much it, right? So the way we tell if something is linear or not is just by looking at whether or not they form a straight line. Because if they form a straight line, it will mean that they're going up by a constant amount. So we can see here, -2 to -1, we do +1, -1 to 0 do +1, 0 to 1 +1, 1 to 2 +1. 0 to 1 +1, 1 to 2 +1, 2 to 3 +1, 3 to 4 +1, right? But then here, -2 to 1, -1 is still +1, that's still +1, +1, +1. But from here, we see that we have 4 go to 1, that's -3, and then we -1, and then we +1, and then we +3. Right? We notice that right here, this is not constant. Right? We go from -3 to a -1, then to a 0, or not 0, we go to a 1 and then a +3. Okay, that was hard. Right? This is why it's not linear. So with that being said, here's a bit more practice for you. So pause the video here and try those questions out. Okay, hope you had some time to check out those questions. Right, so let's get to it then. We got the bacteria and time relation here. So for the time here, it's increasing by 20, right? So 20, 20, 20, 20. But for the bacteria count, or the n, we are increasing by 1 here, but then increase by 2, increase by 4, increase by 8. So it is constant on one variable, but not constant on the other variable, which means that overall it is not a linear relationship. Okay? Next, let's try to graph this out. So again, we'll do table of values. We'll only do 3 values this time, just to save a bit more time. So we have x equals to 0, then y equals to 1. If x is -1, then y is just -2 times -1 plus 1. That's 3. If x is +1, that's -2 plus 1 is -1. Okay, so now on a graph, Right? We have 0 and 1, so that's right here. -1 and 3, that's right there. 1 and -1, that's right there. Right? We get something like this. And as you can see, that's a straight line. So yes, that is a linear function or linear relation. Okay, how about this one? Let's go just do 3 points here. If it's 0, then it's -3. If it's -1, that's 1 squared minus 3, which is 1 minus 3, which is -2. Positive 1 squared, same thing, it's also -2. Got 0 and -3, so that's down here. 1 and -2 is right here. -1, -2 will be right here. Okay, so it will look something like that. And it's not a straight line, so it is not a linear relation. Right? So again, double checking. This increased by 1, that increased by 1. This increased by 2, or -2. This increased by -2, or decreased by 2. Right here, increased by 1, increased by 1. Increased by -1, but increased by +1. Doesn't make sense. That is not linear. Alright, so you can kind of see here. If x is by itself, it's a linear relation. But if it's x squared or any number of exponent, then the relation will not be linear. Alright, now here's a word problem. A new car is purchased for $24,000. Every year it decreases in value by 15%. So now, is this a linear relationship? Alright, so now we can look at it by doing a table of values. Okay, so we have the year on the left and then the cost on the right. Okay, so during its, I guess, 0th year, when we first bought it, it's 24,000. During its first year, it will go down by 15%. So we are working with 24,000 times 0.85 here, okay? Because it is now 15% less in value, which is 20,400. Okay, by year 2, then now 24,400 is going down by 15% again. So 17,340. Another year passes. It goes down from value from 17,000, 14,000. Right, so I can keep going with this. But as we can see here, our year is increasing by 1 each time. That's constant. However, our cost, right, to go from that to that, we are losing 3,600. And now going from 20,000 to 17,000, whatever, it is decreasing. Oh, sorry, I'm out of space here. It's decreasing by 2,060. And then when we decrease it again, right, going from 17,340 to 14,739, is losing by 2,601. Right, so as you can see here, it is not a constant increase or decrease, which means that this relationship is not linear. Right, so that's pretty much it. So if we are given a word problem or a graph, then as long as both changes for the variables are constant, it's a linear. And similarly on a graph, if the line of the graph is straight, then it's linear. If you get curves on a graph, or you get changes like this where it is not a constant change, then it is not linear. So yeah, with that being said, keep practicing and